Hello children, today I am with the Matrices Part II, our first multiplication of a matrix by a scalar number. Here scalar means any number, any real number actually. So have a look on this topic. When we multiply a scalar number with a matrix of an order m cross n, then every element of the matrix get multiplied by that scalar number. Means every element will be multiplied by this scalar number. Have an example. A is equal to 3, 1, 2, 0, minus 1, 4, 5, minus 2, 8. Then we wish to find 2a. As its definition says that every element will be multiplied by scalar. If we multiply scalar by a matrix, then it will be 6, 2, 4, 0, minus 2, 8, 10, minus 4, 16. I think you understand multiplication of a matrix by a scalar number. Now another next topic is addition of matrices. How will you add, whether addition will be possible or not? There are certain questions which arises because matrix it is a different topic. It is not arithmetic, which implies that addition is always possible in arithmetics, but in it is algebra. So let us check what happens about addition of matrices. Matrix addition will be possible only if they are of same order. Means the basic condition for matrices eligible for addition that they should be of same order. Means if first is of 2 cross 2 order, then second should be of same order. If not so, then addition will not be possible. Got it? Now have an example. A is equal to 3, 0, 5, 1, 2, 5, which is 2 cross 3 matrix, and B is equal to 1, 1, 2, 3, 2, 5, which is 2 cross 3 matrix. So A plus B is equal to 3 plus 1, 0 plus 1, 5 plus 2, 1 plus 3, 2 plus 2, 5 plus 5, that is equal to 4, 4, 1, 4, 7, 10. I forgot to tell you that their corresponding elements will be added. Means if they are of same order, if matrices are of same order, then how will you add these matrices? Then we simply write A plus B as sum of matrices, and their respective elements will be added. Means A11 will be added to A11 of the second, A12 of first will be added to A12 of second, and so on. So this is addition of matrices. Now there are some properties of addition. Addition is always commutative, means if you find A plus B, then it always be equal to B plus A. And the second property is addition is associative. That means A plus B, if you add A plus B at a time and then add to C, this will be equal to if B and C are added at a time and followed by A. So addition is associative. Now existence of identity, additive identity. What is an additive identity? If you recall that in additive inverse of additive identity of a natural number, additive identity of an integer, additive identity of an integer is 0, because if you add 0 you will get the number itself. So here which can satisfy this property? Means if you add a matrix to a matrix, then you get the matrix itself. So you can take it null matrix, which is if which is added to any matrix, it will always give the given matrix itself. So if a plus b is equal to a, then b is called additive identity, and obviously b is equal to capital O, that is null matrix. Now, existence of additive inverse. Additive inverse means if there is a matrix and added to any other matrix and it gives a result as null matrix, then both will be additive inverse of each other. Here a plus b is equal to null matrix, which is equal to b plus a. That means b is the additive inverse of a, and a is the additive inverse of b. Okay, got it. It is written here b is equal to minus a. Now move to subtraction of matrices. As for addition, same property follows for subtraction. Matrix subtraction will be possible only if they are of same order. It is also for addition of matrices. Note, corresponding elements will be subtracted. This also happens with addition of matrices. So there, I think there is no difference between addition of matrices and subtraction of matrices. Simply there is a matrix A and B, and we have to find 5a minus 3b. First multiply a by 5 and b by 3. After that subtract them. In this way you can get 5a minus 3b. I think now it is clear from above properties of matrices. Now move to an important operation on matrices, that is multiplication of matrices. So what will happen with multiplication of matrices? What will be the conditions? Are conditions same as we use for addition? Have a look. AB will be possible only if, here is a condition for matrix multiplication. AB will be possible only if number of columns of A is equal to number of columns of B. Number of rows of B. Means number of columns of A must be equal to number of rows of B. Means there is nothing to do with number of rows of A and nothing to do with the number of columns of B. Only matters is that number of columns of A should be equal to number of rows of B. Suppose A is equal to Aij m cross n. A is a matrix of order m cross n, and B is another matrix of order n cross k. Then AB will be Cij, it is symbolic, will be a matrix of order m cross k. Have a look. Which was common to both, means columns of A and rows of B, all are disappeared. Now rows of A have become rows of AB, and columns of B have become columns of AB. So order will be changed, and rows will be of A matrix and columns will be of K matrix. Now how would you multiply two matrices? Here a representation. A is equal to R1, R2, R3. These are rows of A, and B are C1, C2, C3 are columns of B. Then AB is equal to R1, C1, means the respective elements of R1 and C1 will be multiplied, and same happens with R1, C2 and R1, C3. And second row will be formed R2, C1, R2, C2, R2, C3, and third row will be formed R3, C1, R3, C2 and R3, C3. I think it is clear now. Check it by an example. Here an example, AB is equal to, sorry, A is equal to 2 minus 1 1 4 3 0, B is equal to 1 minus 1 0 2 4 5. A is of order 2 cross 3 and B is of order 3 cross 2. I think this is matrix A is of order 2 cross 3 and matrix B is of order 3 cross 2. For product A and B, we must have number of rows of B and number of columns of A. These two must be equal, which is satisfied here. Okay, so I think product will be possible here, and the resulting matrix will have order 2 cross 2. Now multiply them. 2, here we use, as I told you, R1 C1. To use R1 of matrix first, 2 1 3 is R1 and C1 is of matrix second, that will be 1 minus 1 0, 2 into 1 1 minus 1, 3 into 0. All these will be added, and similarly 2 1 3 and C2 of second matrix will form A 1 2 element, 2 into 2 and 1 into 4 and 3 into 5. Similarly we do for element A to 1 and A to 2. By this way we got our matrix 1 minus 5 23 14 of order 2 cross 2. Now properties of matrix multiplication. Like addition of matrices, there are certain properties of matrix multiplication. Matrix multiplication is not commutative. It may be but not necessarily. So we here write it. It is not commutative. Means AB may or may not be equal to BA. It may be in certain cases but not always. So we write it in general. It is not commutative. Got it? Whereas matrix multiplication is associative. Matrix multiplication will be associative. Property third, matrix multiplication is distributive over addition and subtraction. Recall you have studied in earlier classes distributive property, distribution of multiplication over addition on natural numbers, on integers. There were properties, we satisfy them. So you learn from there. Matrix multiplication, A into B plus C is equal to AB plus AC, and property B is B plus C into A is equal to BA plus CA. And for subtraction, A into B minus C is equal to AB minus AC, and property D, B minus C into A is equal to BA minus CA. So distribution property satisfied over addition and subtraction both. Now existence of multiplicative identity. What is it? Multiplication identity. Identity means if you multiply a matrix by its identity matrix, then you get the matrix itself. Like in addition, if we add a matrix to a given matrix, then we get the matrix itself. Same will be for multiplication. Recall that multiplicative identity for number system is 1. If you multiply a number by any number, multiply 1 by any number, you get the number itself. If you multiply 5 by 1, you get 5. That means 1 is the multiplicative identity. Here, for every square matrix A, there exists an identity matrix I. Recall that identity matrix I told you, it is a square matrix, number 1, and all its principal diagonal elements are unity. Matrix I of same order such that AI is equal to IA. If you multiply AI is equal to IA, then this will be equal. Here I is called identity matrix for A. So that there exists identity matrix for every square matrix A. Now matrix multiplication. Matrix polynomial. There are certain questions in exercise to find function of A means where A is a matrix. Many students commit mistake while solving this. So here is clarity about matrix polynomial. If fx is equal to ax cube plus bx square plus cx plus d is an algebraic polynomial and A is a square matrix, then fa is equal to, simply replacing x by A, you get a cube ba squared plus ca plus di is called a matrix polynomial. Here unit matrix I and A are of equal orders, means order of I and A must be equal. We can say that we choose I is of order as of A. Important thing is that here it is written as di, but in question it is simply d. But while when you write matrix polynomial, you have to compulsorily write I as a multiple of constant. If constant is alone, having no other variable, so you have to write I here, okay? Because if you not write I here, then this addition will not be possible, because you cannot add a number to a matrix, because all all these will give a matrix, this will give a matrix, this will give a matrix, this will give a matrix. Then how would you add to a constant to a matrix? There is no such rule. So we write here I as a multiple of d, so that the matrix addition can be possible. I should written that's all for matrices part 2. We will soon come with part 3rd. Okay. Till then, goodbye and good day. Thank you for watching this video. If you have any query about any topic, then you write in comment box and let me know, so that I could clarify all these properties and all these definitions. Thank you for watching this video.